आइए हम सुने विज्ञान की अनकही कहानियां।
The Himalayas aren't just majestic, they are a geological diary. Hidden in their igneous rocks are clues to earthquakes and shifting ecosystems. Today, we sit with Dr. Sen of the Wadia Institute of Himalayan Geology, who deciphers these rocks' structural and metamorphic secrets. Their work, a bridge between ancient earth and modern survival, in these three ways. Listen in.
I am DrKaushik Sen. I am scientist E in Wadia Institute of Himalayan Geology. I originally hail from West Bengal. I did my PhD from IIT Kharagpur, and after that I joined Wadia Institute. My research specialization is basically structural and metamorphic characterization of rocks, mostly the igneous and metamorphic rocks. And I see the rocks in micron scale, in the grain scale or mineral scale. What is the chemistry of those grains and minerals, and what kind of deformation in terms of crystallography and crystallization those grains have experienced. And from that, I try to interpret the overall evolution of the Himalaya and its implications in terms of seismology, sometimes fluid mineralization, and alternative energy and all that. Those are applications part which my study can complement. This study complements three very key aspects that are related to our day-to-day life. I'll explain them one by one. One when we can interpret that which part of a certain area is more deformed than the other by studying the crystals or the minerals and grains, we can map or localize some zones which are more prone to deformation than others, which in turn can help you predict that whether these zones are more susceptible to earthquakes or not. So, in a large scale, when a geophysicist will try to predict the earthquakes or study the earthquakes, my study can give them a initial push that concentrate on these areas more. These areas are more prone to deformation than the surrounding areas. This is one aspect which my study complements. And second is that you see, whenever some important nowadays, it is all about the like alternative energy source, like rare earth. We are focusing on rare earth, we are focusing on lithium and stuff like that. In many cases, these kind of rare earth elements or elements, the concentration of these rare earth elements depends on how a fluid has migrated and accumulated somewhere. Now, the flow of the fluid or its accumulation will depend on the weaker zones. The zones within the rock which are weak and the zones which are more deformed, along that the fluid will migrate easily. So that by that also we can predict and we can model and we can say that so for certain kind of rock type, if those rare earth elements are found in this rock type, these are the regions within these rocks where it is more likely that these rare earth elements will be concentrated because of fluid evolution. That is the second thing. And the third thing is, nowadays, as you know, that a lot of emphasis are being given on hydrogen as an alternate energy. Now, the one thing is the exploration of hydrogen. There is a problem with that. That hydrogen tend to migrate within the rock, in the pores and spaces. So maybe you have stored hydrogen in some geological formation. Hydrogen storage is a big thing nowadays. Everybody is trying through mathematical modeling, to experiment and all that. Hydrogen sometimes will tend to percolate. Means you have stored some hydrogen, but after say 20 years, you said there is no hydrogen there. It has just escaped. So, by showing what kind of rock or what kind of minerals that are more robust and means less deformed and all that, where these will be ideal for storage of hydrogen. Even storage of carbon dioxide also, means you entrap carbon dioxide from the atmosphere, store it somewhere and try to mitigate global warming also. So that is also a very new emerging thing that is being done, that is being tried, and in India it is still in a nascent stage, I would say. but it will grow, it will catch up very fast. And currently we are also we have started some experiments that we are hitting some certain kind of rocks which are more prone to producing hydrogen. They produce hydrogen. Once they react with carbon dioxide, they produce hydrogen. So there are two things are happening. One is that your CO2 is getting sucked, so CO2 in the atmosphere is getting reduced, and at the same time it is producing hydrogen. So though that we have started just rock powders, and we are heating it with carbon dioxide water, and we are checking how much hydrogen it is producing. So you can say, okay, these kind of rocks are more likely to produce more hydrogen than other rocks and stuff like that. That's what my application part of my study lies. My past research area was basically to study the fabric of a rock. Fabric means, like, fabric is like in general term which you use, fabric, that is the same. Means which way the rock is aligned, which way the mineral of this rock are aligned, so that we can hear the how deformation has taken place and all that. For we used magnetic very low field magnetic susceptibility UT impart, and we used to figure out. I did my PhD in Aravalli region of Gujarat, and that was the study. And after that, when I came to Himalaya, I started study them more like, instead of like bulk rock samples, like more like the mineral scale, micron scale, in scanning electron microscope and petrographic microscope, to find out that whatever we are seeing today at a large scale of Himalaya, what is happening in micron scale in the Himalaya, which eventually is affecting whatever is happening is large scale. And my future will be, that's what I just explained: hydrogen storage and hydrogen production. What kind of rock and what kind of rock will be an ideal reservoir to store hydrogen, and what kind of rock will be really ideal to produce hydrogen at the same time. So that's what my future study will be. India is emerging in this field, and but not only India, most of the countries are actually emerging in this field. It started in Iceland. This whole idea, Iceland and Alaska, where they have lots of geothermal, and volcanoes and stuff like that. They started that, okay, if you can trap the carbon dioxide, store it somewhere. So that experiment started. It was not like 20 years or something like that. Nowadays, uh, uh, other countries have started catching up, like Europe and USA, but we are not very far behind, because they were not very ahead either. But then right now the central government is spending a lot of money, giving a lot of impetus, and giving a lot of workshops are being done. Awareness is being done. They have been asked, just please do something on this here also. Alternate energy, basically hydrogen and rare earth elements. So India is emerging, but most of the countries are emerging. So it is India is not far behind. The industries that thing is that the first and foremost, the industries that will be interested in our work are the oil industries, because petroleum is getting dwindled, and they are also looking for alternate energies like hydrogen and rare earth elements. So we usually, the first guy to get in touch with from our field, academic field to industrial field, are the oil like Oil India Limited, ONGC and stuff, and they have lots of data also. They have lots of samples also. So this is where we have. They are the most likely people who will be most interested in our or anyone who is interested in alternate energy, green energy, and anyone. But it mostly will be oil companies, because they are spending a lot of money on this. They say this critical mineral and hydrogen. No, we can store it. It basically depends on what kind of rock. So that experiments is still going on. What will be the ideal rocks? Some rocks are good, some rocks are bad, and some rocks are very good, but they may not be present at all at some places. So say for example, there are twofold problems if you talk about Himalaya. Is that, first of all, if you are thinking about large scale storage of hydrogen or carbon dioxide in the Himalaya, it can be an environmental hazard. Because it's a very environmentally very ecologically sensitive region, and sometimes what will happen, that CO2 and hydrogen, if you store it for a long time, it may weaken the interior part. Now then will more prone to landslides and stuff like that. So those things has to be taken into account also. Very remote area, rock is really solid, and it doesn't really react at all with the hydrogen CO2. So these experiments are and they are fun to do with these experiments. We do that, and we are planning to do it even more. And that is real challenge, but that is the real fun also. My research papers mostly in the Himalaya. I have worked about the Himalaya can be segmented in various fault zones, right? Main central thrust in the South Tibetan detachment, the Karakoram fault, the Indus Suture zone, which are major lithological boundaries, which are uh, prone to seismotectonic activity, seismic earthquake and landslides and stuff like that. My mostly means how the rock that are present within those fault zones and the rocks which are present away from the fault zone, how the deformation or the crystallography varies, so that I can predict that okay, this area is the deformation intensity is this much in this area, and it is this reduces like this or increases like this, so that's what I say, that so that we can give a broad map that which areas are more prone to natural hazard and natural disaster. And secondly is that the age, at what time it all started, at what temperature the deformation has started, whether the deformation is still going on or the deformation has ceased and some healing process is going on. So these things has a huge seismic means implication in terms of earthquake, that how the grains that are present at a certain area, how they are deformed, and earthquake and the flow of fluids. That's what I have done mostly. I have done mostly work in the Karakoram area. Ladakh is one of my means the area which I have worked most. I've been working in Ladakh for like 18 years. So Karakoram and Somurari and all those areas I have worked, from deep mantle rocks that have came from deep inside the earth. Their crystallography, their mineralogy, the implications in terms of alternate energy, the implication in terms of seismotectonics and all that, and deformation obviously. And secondly, I have worked in the Kumaon region and Garhwal region. Now I have just started working in the Arunachal, Northeast Himalaya. So I'll probably be working in the Northeast for a long time in the next 10 years and stuff. Okay, that's the difference is huge. Means, say for example, the geological differences between, say for example, Ladakh and Arunachal is huge, because Ladakh, the Himalaya is much older. The formation has taken place at a earlier stages, and most of the rocks are exhumed to a certain stage, and they are like means roughly you can say they are more or less in equilibrium. So there are chances of earthquakes are very less. So some fundamental studies or how things have happened in the past, those studies are very ideally done in those areas. Ladakh, there are earthquakes, but firstly because the human settlement is very less, and secondly the earthquakes are not very strong. So seismotectonics or earthquake is not it is not that prone right now. But landslide is a huge problem there, because there are hardly any tree covers in Ladakh. So even a small amount of rain can wash away a lot of. Yeah. On the other hand, in Arunachal, it is thick green forests, but the Himalaya is very young. The rocks are very young. They are still means uh, at the infancy stage, means they can go haywire anytime, means they are still evolving in a term, just like say the difference between a 25-year-old and a 65 years old, how they will behave in a certain time. So that is the basic difference basically, because this is a young Himalaya, that's a much older Himalaya, old matured Himalaya, young immature Himalaya. So earthquake is uh, very prone to earthquake, and some major earthquakes can happen in that part. And so that is the major difference if you see between these two in Arunachal Himalaya and Himalaya. So whatever we are doing, we are planning, say for example, new roads or tunnels or railways in Western Himalaya, Kashmir or Ladakh. It might create problem, but uh, means the probability is much more in the Eastern Himalaya, because it is more very easily deforms on slides and stuff like that. Say for example, Sikkim, and say for example Arunachal parts and Eastern Arunachal Himalaya. So it's a altogether very different ball game, Western Himalaya and Eastern Himalaya. The DST is putting a lot of impetus on this. There are many things to DST are putting a lot of impetus. The one thing is that alternate energy and green energy and critical minerals. The DST is trying to means putting a lot of efforts, awareness, and fund and stuff like that. And other subjects which I am not an expert also, I should not talk much, but those climatic things and glaciers and all, the DST is doing a lot of things. DST is doing its best, and Minister and I hope they continue working, continue understanding the importance of hard rocks, means igneous and crystallized or not, in terms of mineral resources, in terms of critical minerals. It is extremely important to work on climates and glaciers and all that, rivers and but these things are, because say for example, without, if you do not run out of some certain critical minerals, you won't be having any laptop or mobiles maybe after 50 years, right? So it is that important, and BDST is doing it, and I hope they continue to do it and do some more for fundamental science, which basically has more implications towards, because if you do not know the fundamentals, how you are going to apply it? Extremely important thing is that unless the common people can connect himself or herself to whatever the present scenario trend is going on, they means the gap will mean that they will never understand that what needs to be done and what is being done and what is his or her responsibility towards the society as well. The do's and don'ts in terms of science, that is very important, and to in a very legible language and in a way that is very easy for them to comprehend and that are useful also for them. So that is the, in fact, that is the fundamental part, that is the base of the pyramid, to be honest. So that is obviously, that is the most important.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.